Hello everyone, my name is Divya. I am from F1T3 and today I am going to discuss a past year question from chapter 4. Question number 17a. Fluoromethane and carbon tetrafluoride are tetrahedral molecules. Using the Lewis structure and dipole moment of these molecules, deduce their polarity. So, in this question, first we should analyze what they are asking in this question. So they gave two molecules and they wanted Lewis structure, dipole moment and polarity. For fluoromethane, as you can see, the carbon atom is at the central and this is H atom, H atom, H atom and F. And all atoms have completed the octet. And this is the Lewis structure for carbon tetrafluoride. The carbon atom at the central, followed by the fluorine atom, fluorine atom, fluorine atom, and fluorine atom. And this Lewis structure has also completed the octet. So, if you draw the both Lewis structures correctly, you will get 2 marks. And followed by the class of compound, where the class of compound for both structures are AB4. Next, the number of bonding pair plus the number of lone pair, which is equals to the number of electron pair for the both molecules are 4 plus 0, which is equals to 4. And the basic shape for both molecules are tetrahedral. So followed from that, the molecular shape, the name of the shape is also tetrahedral and tetrahedral. And this is the drawing for fluoromethane, the carbon atom at the central, followed by the other atoms in the molecule, and you can see the bond angle between the atoms are 109.5 degree. And this is the molecular shape for carbon tetrafluoride. The carbon atom is also at the centrum and followed by the other fluorine atoms. And the bond angle for this molecule is also 109.5 degree. And if you answer this question correctly, if you answer this part correctly, then you will also get 2 marks. Okay. And next, the type of repulsion. For fluoromethane is bonding pair to bonding pair, and also the same for carbon tetrafluoride, which is also bonding pair to bonding pair. And this is because there is no lone pair in the structure. Okay, this is the drawing to show the polarity of fluoromethane. The carbon atom at the central, followed by the other atoms. Okay, you can see there's an arrow here, which is used to indicate the direction of a bond polarity from less electronegative element to more electronegative element, which means that The hydrogen atom here is partially positive compared to the carbon atom here, which is partially negative. Okay, you can see partially positive, partially positive. The arrow is going there. Okay, you can see, and the arrow here is going to fluorine atom, which means that the carbon atom here is partially positive compared to the fluorine atom, which is partially negative. So next, let's see the drawing for polarity for carbon tetrafluoride. The carbon atom at the central, followed by the other fluorine atoms, and all the arrows are pointing towards fluorine atom, which means that the carbon atom is partially positive compared to the fluorine atoms here, which is partially negative. Okay, let's see the explanation for dipole moments. The CH and CF bonds are different in electronegativities, and dipole moments are pointed to different directions, although the shape is symmetrical. And the next explanation for carbon tetrafluoride, the CF bonds, fluorine atom is more electronegative than carbon atom. Dipole moments can cancel each other since the molecular shape is symmetrical. So if you answer the both explanations correctly with stating the difference in electronegativities for each of them, then stating the dipole moments, this one also, the dipole moments can cancel each other or not, and the shape is symmetrical or not. And the next thing is you have to state that whether this molecule is, the mole of the molecule is equals to 0 or not. For fluoromethane, the mole is not equals to 0, while for carbon tetrafluoride, the mole is equals to 0. So you will get 4 marks in total for explanation. Then you have to state the polarity of the molecule, whether it is polar or non-polar. For fluoromethane, it is a polar molecule, and carbon tetrafluoride, it is a non-polar molecule, and you will get 2 marks here. Okay, that's all for question 17A. So let's continue with question number 17B. Iodine pentafluoride is a colorless liquid with a pungent odor. By using VSEPR theory, predict the geometry and bond angles of this compound. Show how the orbitals of the central atom undergo hybridization. Draw a labeled diagram showing the overlapping of orbitals in the molecule. So the first thing that we have to do is analysis the question. First, we have to underline the VSEPR theory. Then, they ask the geometry and bond angle. Then, they ask about the hybridization. Then, they ask the label diagram showing the overlapping of orbitals. So, this is the Lewis structure for iodine pentafluoride. The iodine atom at the central, followed by the other fluorine atoms, and the total number of valence electrons are 42, and you can count there are 40 here, and the balance 2 are here as lone pair. And let's see the class of compound AB5E. the number of bonding pair plus the number of lone pair, which is equals to number of electron pair. 5 plus 1 equals to 6, and the basic shape for this Lewis structure is octahedral. So next, the name of the molecular shape is square pyramidal, and this is the drawing. The iodine atom at the central with 2 lone pairs and 5 fluorine atoms. The bond angle here, should be less than 90 degrees. And the type of repulsion is bonding pair to bonding pair and lone pair to bonding pair. And if you answer all this correctly, then you will get 3 marks. So this is the electronic configuration of iodine pentafluoride. This is the sp3d2 hybrid orbitals, and the central atom is iodine. This is the ground state. There are 5s, 5p, and 5d empty orbital. And when we excited it, it will become like this. And if we hybridize it, then it will be like this. So it is a sp3d2 hybrid orbitals. And if you answer all the ground state, you will get 1 mark. Excited state, you will get 1 mark. Hybridized state, you will get 1 mark. And if you identify it, the sp3d2, then you will get 1 mark. So total you will get 4 marks. So this is the drawing to show the hybridization of iodine pentafluorine. Okay, you can see the 5s orbital, the 5p orbitals, and the 5d orbitals are mixed to form sp3d2 hybrid orbitals. Yeah, you can see the sp3d2 hybrid orbital of I atom is overlapped with 2p orbital of F atom to form sigma bond. And the same goes all here. The explanation is the same for here. And we don't have an overlap here because this part is for the lone pair. And if you you will get 3 marks. Here, if you draw the shape of the hybridization correctly, then you will get 1 mark. And if you draw all the overlapping correctly, then you will get 1 mark. And if you label all the overlapping correctly, then you will get 1 mark, and the total is 3 marks. So that's all for question number 17b, and thank you.
If you like this video, don't forget to subscribe.